Okay, so this is the latest thing that's come in. Just so happened I finished the MOSFET amp which I showed in the last video, and then this thing turned up. And this thing is a Laney Supergroup 100, and I would presume it would be used for bands, because it's got bass input here and a treble input there, and various gain controls for, I think that's for the treble input, yeah, gain 2, and gain 1 will be for the bass input. You can see all that. And then you've got all sorts of other stuff. We've got treble control, middle control, bass, and presence, whatever presence does. It's always been a mystery to me what presence does, but maybe we'll find out. Anyway, this unit is working because I've had it in before to fix, and when I had it in before there was a resistor gone high in the power supply chain that fed the preamp section, I think, and so consequently the preamp was not getting its voltage, and that was a really easy fix obviously. But now the idea is to refurbish it completely, because it'll have loads of rotten old electrolytic capacitors in it, and also as I said before, it had a resistor that had gone high, so I think I'm going to go around and check all the resistors, and it might be a good idea to replace all the resistors as well. Depends how much he wants to spend on it, I suppose, this guy. And I'm lucky enough that I've got some very good information which I downloaded last time I had this thing here, and I've got a very nice set of circuit diagrams, and this is the power supply. I hope you can see it okay. Normal mains transformer, that's the HT winding, then you've got a bias winding and the filament winding with a centre tap to earth, which I'm not an aficionado of valves, but I think that eliminates hum if you connect the centre tap to earth, or helps with hum. And fairly simple on the bias, it's just a 4004 resistor, 10 microfarad capacitor which will need changing, then you get minus 54 volts out. And on the HT you've got loads of, well, two 4004s in series in each part of the bridge, so that would have a rating of 800 volts PIV, something like that, maybe more than that. I'm not sure on the 4004s what their PIV is. And then we've got the standby switch, which I find a bit bizarre, but I suppose it makes sense. When it's in standby as it is now, in other words, normally when you're using it, the DC would go straight through, or the rectified AC would go straight through, but in standby you've got a 1 microfarad and a 220. So my only conclusion of that is it puts a small amount of spiky DC, which hasn't been smoothed, through that circuit. I wouldn't think you'd get much out of the other end. And then it goes into the filter capacitors, and what they've done here is they put two 33s in parallel, 66, then series, so overall you're going to get 66 microfarad. But what they haven't done, they haven't put any equalization resistors across these capacitors, and if you had one capacitor, set of capacitors that was out of balance with the others, you could probably get more voltage on one side than the other. Well, you would do. And I think they've done this to keep the voltage rating of the capacitors low, because there's 600 volts on here. But you know, that could be disastrous without having what do you call it, balancing resistors across the capacitors. I mean, if the capacitors went out on one side, you might get 500 volts on there or something across these two. So that's not the, I think I would, in theory, when I refurbish this, I will put balancing resistors across it. So, moving on, that's the power supply. We've now got the preamp. And as far as I can work out, we've got two identical stages here, one's for treble, one's for bass, and I can't see any difference in the components. So how they can be treble and bass, I don't know. All the capacitors are the same, all the resistors are the same, until you get to the outputs on the pot. And on the treble output, we've got a 470 with a 270k resistor with a 270 PF across it. So I guess that would, in theory, allow more treble to go through, which is fine. But on the bass section, there's none of that. They've just got it going straight into the next section. So I would expect the bass section to be more or less flat. And after that, we've got a bit more voltage gain. And that voltage amplifier is now feeding into the grid. No, that's also a voltage gain amplifier. So we've got two more stages of voltage gain there. Yeah, plate to grid, but no coupling capacitors. Oh well. No DC blocking capacitors. Oh well, I suppose they know what they're doing. And then coming out of that cathode, yeah, that would be, no, that's a cathode. There's got to be a cathode follower, that. Yeah, that's a cathode follower, because rather than taking it off the plate, they're taking it off the cathode. So it's just a buffer with no voltage gain, just to drive the next circuit. And then we've got all this rubbish here, which makes no sense whatsoever. It doesn't say what the controls are, it just says T and M, oh, and B. Maybe that means treble, bass, and yeah, mid. We got a mid. Yeah, that makes sense then. And then it comes out to the power amp. When we look at the power amp, we've got another set of voltage amplifiers in the same tube, valve, whatever. You know, these are AX 12AX X7A. Well, it's probably an ECC 83 in this country or something similar. And on the outputs of these, I would expect a complementary signal. In other words, one's going positive while the other one's going negative. So whether it is or whether it isn't, I don't know. But the only difference I can see between these two amplifiers is one's got an 82k in its plate, its anode, not plate, anode. Plates are American and things to eat on. And on the other one, it's got 100k on the plate. And so what's the reason for that? I don't know. I'm not a lover of valve equipment. I don't know a lot about it, to be honest. I prefer transistor equipment where you can get your bloody fingers in there without being killed. And we got some output valves, EL84s, classic valve, and they're being running basically paralleled up. HT coming off there, 600 volts presumably after the choke, maybe a bit less because the choke will drop a bit of voltage, and that'll go through the 470, which will oh no, that's to the grid, right, fine, forget all that rubbish. The basic valves get their feed obviously through the transformer, the audio speaker output transformer, center taps, and then that feeds that parallel pair, and of course the other valves at the bottom feed the bottom half of the transformer. So I would expect this circuit to have one of them be doing the positive half cycles and one do the negative half cycles of a sine wave, and then you've got your speaker outputs, and I think they're impedance selectable 8 or 16 ohm. And just going back again to this power supply line, you've got roughly 600 there, and then you've got these capacitors again in series, they'll need sorting out. Then a bit of voltage drop through a resistor, and that I think was what went high before. So, and then on further on you get another set of capacitors, another bit of volts drop feeding, well, that feeds this stage obviously, and then that'll feed the preamp stage. But this is a very well drawn out circuit, and if I look at when it was done, it was done in 2008, so I congratulate the guy who drew all this out in detail. So what I'm going to do now is I'm just going to turn it on and make sure it works, which I'm sure it will. Okay, it's been warming up. Got 400 Hz going into the base at the moment, and I've set it into standby mode. Alright, I've set it into standby mode. This switch is a bit confusing. You'd think standby would be down if it was in standby, but it's not, it's up. So if I switch it now into out of standby, got 400 Hz going in, and as you can hear, that's going into the bass channel, which is channel 1 I guess, and that's fine. A bit more volume maybe. Bass makes a bit of difference, middle makes a bit of difference, treble makes not much difference. The only thing I don't like is the fact you turn this down and it doesn't completely go to zero, which is I think a bit annoying, but I'm not going to worry about that as it's not my amplifier, I couldn't care less. So having looked at that circuit, I wonder if that bass amp output is actually flat across the range. If I turn it up now and change frequency, it's 1K. That's 10K. Well, you won't probably hear that very well. Treble, turn the treble off. Up, it works, yeah. It's got a lot of hum if you turn the volume up. That's 10K. 12, 13. So I suspect that the bass input is completely flat. Whereas, that is so annoying. Turn the treble down. That was at 10K, so my ears are still fairly good to 10K. So I suspect that bass is flat. In other words, you could put full audio spectrum music into that. and if I go into treble, and that'll be this one, that is considerably louder. Treble control works, of course, and mid does nothing, bass does nothing, and that's down to 1K. Well, I'd say that one was fairly flat as well, but I don't know. That's down at 300 Hertz on the treble. I don't know, I'm just going to unplug it, turn the gain up, fair amount of main tom, as you can hear. I suppose in theory that should be 100 Hertz after it's been through the bridge rectifier. I think it is, sounds a bit like 100 Hertz. I could stick a frequency meter on it, but can't be asked. But anyway, turn all that rubbish off. I think I'll just stick. That's the usual favourite, Parliament Funkadelic, One Nation Under a Groove. That's all I can play of that, otherwise I get YouTube jumping on me and doing whatever YouTube do to people who break the law. So, it sounded fairly good anyway. And I haven't measured its output, but I don't really want to get into that at the moment, because it probably will do 100 watts per channel. And I guess it's the sort of thing they'd use in the 60s on stage. They stick a bass guitar probably in there and some other guitar in there, whatever. But I wouldn't want to carry this bloody thing around. It weighs an absolute ton. But I suppose you get used to it if you're a roadie. So what I'm going to do is get it out of its box, which is a major undertaking to get it all out, and then I'm going to just go around looking at all the resistors and measuring them, and I'm going to make a very long list of all the capacitors, because there'll be coupling capacitors and whatever capacitors, and I think they all really need doing and changing. Whether the resistors all need changing, I don't know, because they do tend to go high in valve equipment, especially of this age. It's probably from the 60s, I imagine. So that's what I'll do now, get the bloody thing out of its box and have a look inside. So here's what it looks like inside, and that's your preamp section over that end, and at least I think it is. Yeah, it is. And various valves, various capacitors, obviously. Resistors look fairly nice actually. I should measure them, and if they're checked out fine, then I'll leave them alone. If I go further along, lots of nasty, hideous electrolytics. How many have we got? 1, 2. What's this one? 0.1s. Might have to check them. Some of these look like they've been replaced. I can see solder, whatever, on those. But I'll have them out anyway and check them. And yeah, we've got nasty electrolytics all the way along there. And conveniently, whoever put these in has made them hard to see what the values are. But I can see that one is 33. No, I don't want to zoom. That one there you can see says 32 on it. I think somebody may have replaced these at some time. But can't see any date codes, that's a problem. 350 volt DC. 350 volt DC. So diodes are interesting. They were supposed to be 1N4004s, and I don't know what these are, but they're certainly not 4004s, but they look to be a higher current rating. I think I'll test them, but if they test okay, I'll just leave them alone. Oh yeah, there's the mod I did. When it went faulty before, the resistor went high between the preamp and the power amp HT, and I didn't have the right resistor, so I just stuck this in. But when I do sort this thing out, I shall put in the correct resistor. And what have we got here? Another diode. Another diode. There it is, diode. I didn't see that on the circuit, but I'll have a look around anyway. We've got lots of wire wound resistors. Wire wound, wire wound, wire wound. I measure those, check those are alright. They don't normally cause too much trouble unless they get under a lot of stress and get too hot. And that's about it really. So I think I've got the long tedious process of making an itemised list of all the parts I need to get for this, which I shan't bore you with. But I wonder where that diode is then on the circuit. I never saw that. Never saw that diode. Maybe that was a later revision to the circuit. Can't see it in the power amplifier. Oh yeah, right, that'll be that one in the bias for the well, 54 volt minus bias. Okay, that's all that was. Okay, I'm going to go and start on the very tedious process of measuring all the resistors and writing down what capacitors I need. They're actually surprisingly good, these resistors. There's two over there which are supposed to be 100k. Tested those, which was 68k, and they were virtually right. But I just measure these and the camera's going to fall. See how good they were. 0.101 mega ohm. So that's pretty good. Anyway, I'll continue. So I pulled out one of these 32 microfarad 350 volt, and I'm going to just measure it. Seems pretty good to me. ESR 0.78. I don't think that's too bad at all. But I'm still going to change all the electrolytics, because who knows how long they've been in there. But what else did I do? Oh yeah, one of these which had been bodged in, it's a 0.1 bodged in by somebody, 0.1000 volt, and hang on, I'm going to unwind this rubbish, get rid of that. First, this is supposed to be rated at 1000 volt. Now this thing here is an insulation tester, which you would commonly use, electricians would use to test the insulation between live and neutral and earth and whatever. But it's got selectable ranges of 250, 500 and 1000. So I found it's quite convenient really for testing capacitors. So I've set it on to 1000 and I'm going to press test, and it immediately goes high resistance. So I think that means that's a good, well, it does mean it is. It means it's a good capacitor. Don't know what, don't want to touch it because it's got 1000 volts on it. Turn that off, and now it'll be charged up to 1000 volts as well. And yet underneath it says 250 volts. So what the hell does that mean? AC, AC. I don't know if you can see that. I still don't want to touch it because it's charged up. Okay, it's got DC rating of 1000, AC rating of 250 volts. So I think that's good. That can go back in, I think. Just tidy it up because it was a bit bodged in there. But the other thing I found, which was, let me get rid of all this other rubbish on the bench. So I was checking the diode bridge here with these weird looking diodes. I'll go to the first one. That's fine. I'll go to the second one. No reading. Reverse the probes. Absolutely no reading. So that diode's dead. That was part of the bridge. Absolutely no reading. So that diode is dead, and so the bridge rectifier couldn't have been working properly. Effectively, I think it would have been working as a half-wave rectifier. So that's interesting, isn't it? So I don't know, I think I'll put the original diodes they specify in it. 50, what was it? 50, 1N40, 1N4004s in series. So I might go for a slightly high power diode. I'll see what I can find. Could put 54, 1N5404s in there, but they're a bit big. 3 amp diodes. I mean, this thing doesn't take 3 amps, does it? Don't know what it takes. Less than an amp probably on the HT. Yeah, less than an amp. If it was half an amp with the HT at 600 volt, that'd be 300 watts. 300 watts. Yeah. So I think 1N4004s would be okay. I might look for something slightly bigger than that, but not too big. So the other thing I've done, I've checked the these polystyrenes. I think they're polystyrenes, and they're all testing fine. And I've tested them at 500 volt on the insulation tester, and they're absolutely fine. There's some more there. There's one under there which I've tested, and a bloody stupid camera. But anyway, I've tested that one, and that's fine. This bloody thing. Somebody needs to buy me a decent camera mount. Anyway, you've got some 5 watt resistors here. What are they? 470 ohm. One of them was reading 490. I don't know how critical that is, but I think for just how much it would cost, I'll replace them all. The others were okay, but 490 is going, sounds like it's suddenly gradually drifting high. So that's about it now. I've got to make a list really of all the components I'm going to need for this, then put an order in. Okay, well, all the components have turned out for this amplifier, and just look how small that capacitor is compared to what it's replacing. So what have I got here? Got loads more capacitors, some resistors, whatever, and some diodes. But how much I'll do of this today, I don't know. This is extremely hot today, and it's 10 to 1 in the afternoon, and it's already 28.3 in this workshop. So I'll get on with doing something anyway. Okay, all components have now been done. New bridge rectifier diodes, went for 1N 5404s, bit over the top really, because they're 3 amp rated, but whatever, they're cheap enough. And new capacitors all the way along there, and another diode there, another capacitor, 10 microfarad, and right over the end, 2 more capacitors, and those 2 over there also. Okay, so I think the next thing to do is to test it with a variac, because don't like sticking mains straight on it. Wind it up gradually, see how much current it takes. Okay, I'm on the other bench and I've got it switched on and I've got the variac set to 0. I'm just going to gradually wind it up, see what the meter says as I go. It doesn't really start working properly, this meter, till you get to 70 odd volts. There we are, 68, 70, 8 watts so far, 84, 90, 100, that's 16 watts, seems to be okay. 130, 150, nothing's blown up yet. I think it's going to be okay. Nearly 200, 50 odd watts, 210, 220, let's take it to 230, 100, 110 watts. Well, I guess that's okay. I never measured it before, so I think the thing to do is to just try it now. Wind that down again. Okay, back on this thing again. As you can see, it's in a state of disrepair on the other bench, handheld. After I'd done that first test, it was drawing 100 watts. Did think that was a bit high, but I plugged all the, got it all set up, plugged in signals and speakers and whatever, turned it on, no output. So after a while I noticed there was a smell of something burning or getting hot. So turned it off quickly, turned it upside down, and I found 2 of the diodes had blown in the bridge rectifier, and they're 3 amp diodes. Don't know why they blew. There's a fuse in there. That's a 1 amp fuse, although it should be 750 milliamps. But after a lot of messing around, I thought there's got to be a reason why this is happening. So, trying to cut a long story short, on this circuit we've got a choke, which I found was getting quite hot. 20 Henry choke. I took all the valves out and ran it without any valves in it, and it was getting quite hot after a few minutes being turned on. So there's nowhere for the current to go, because it only goes to the valves, which weren't in, and a 2.7k. So there had to be some problem on the output of the choke. Anyway, I measured the output of the choke. There's about a 4 ohm resistance roughly to earth. So, having poked around a bit, I thought, gotta get the board out, which is not something I wanted to do. And what did I find? The wire that feeds from the choke, which is this orange one, that goes to this point here on the other side of the board. And when I soldered this resistor in, of course it had fallen off. You can't see underneath there, but whatever. And also the wire on the other end of that 2.7k, that had fallen off as well. It's a stupid bloody idea, sticking the wires on the back of the board like that. So what I'm going to do is because as soon as you heat these pillars up, these aren't secured on, they're just soldered loosely, these wires. So what I intend to do is that one can go over the top like that. There's another one that goes over to the lower voltage connections on that capacitor, I think. I'm going to reroute that one on the top as well, and that should sort the bloody thing out. hopefully I got enough diodes. Need 2 diodes. I can take that one out because that doesn't need to be a high voltage diode. That's only minus 54 volts bias voltage, and I've got one spare one, so I'll have to find something else to go in there, but it doesn't need to be anything special. It doesn't need to be high current or high voltage. Right, so it's all back together and whatever, fixed hopefully. So I'm going to wind it up again on the variac, see what it does, see if it blows up and see what it does anyway. So what we got now, 30, 40 volts, 60 volts, no, what's that say? 80 volts it should, it doesn't make sense. That's reading 100 and that's reading 80, whatever. Gradually going up. 150, only 27 watts. I have to check my calibration on this. 180. 190. 70 something. Still drawing another about 100 watts. But maybe that's normal. Hasn't blown up at 220 volts. I'm terrified of this bloody thing. It's the fact that it's got bloody 600 volts flying around in there. It'll either kill you or throw you across the room if you do one thing wrong. Okay, well, maybe it's okay. If I put it in standby, with the switch on the front, it drops it to 50 watts. So I guess the output valves are drawing current. That flicked it up a bit. Well, it hasn't blown up. Go right up to 230. Doesn't smell like anything's melted. Alright, I'm going to wind it down again. I'm going to shove it right back on the other bench and stick some signals into it. If it doesn't work now, it's going over the roof. Okay, I'm back on the other bench. I've got 200 millivolts and signal generator going into it at 1 kilohertz. I'm just going to wind it up again on the variac, so stand by. $100 volts, give it a chance for the valves to warm up, and turn the gain up a bit. How long does it take to warm up? How long do the valves take to warm up? Probably a fair time at 100 and whatever. Aha! A tone. A tone. Turn that down. Voltage going up 160. Right, that's full 230. I think that's working. Bloody knob though, it doesn't go down to 0. Hideous. Try the treble input. Yeah, that works as well. Okay, I think it's fixed. I'm going to do some measurements on it now before it blows up again. Okay, usual setup. I've got 1 kilohertz going into it and 8 ohm dummy load, and I'm measuring across the load with a scope and also the HP audio analyzer, which is set at the moment to read in watts. And go over to the scope. I've got the volume right down and the audio analyzer is reading 0.2 watts. So let's turn the gain up. I don't know where the tone control should be on this, but well, not too bothered really. So that's 11 watts, 30 watts, looks slightly distorted maybe, 40, 50 watts, nastiness creeping in, 56 watts, 64, 72, 85, and it looks pretty nasty. Oh well, let's turn it down again. But then again, distortion is part of the sound or something. Or people used to like the sound of valve amps because of the distortion. But I suppose it didn't matter if you were on stage. Nobody would have cared what it sounded like particularly. Anyway, let's do a distortion measurement. So I'll go up to the audio analyzer, switch it back into AC level, and then into distortion. Right, in the moment with volume right down, 1.9%. I'll just crank it up a bit because I can't measure the power now while I'm doing this. Just look at the scope. Right, that's coming up to, I don't know what it's coming up to, 1.7%. That's not too bad. Now it's starting to break up a bit on the scope, and it's 2.6, and that's near the peak again. Right, that's probably nearly 85 watts there. That's 3% distortion. So I guess it's not too bad. I don't perhaps think the average person would notice that too much. So I could try and do the frequency response on it, but I can't honestly see a lot of point because I don't know where the tone controls are supposed to be set. All the numbers are scratched off them, and I've tried to set them in the middle, but whether that means what that means on an amp like this, I don't really know. So I think that's all I'm going to do with it, really. Yeah, the frequency response, I'm guessing is going to be not too good at the lower frequencies because of the transformer output. It'll probably be okay from about 30 Hertz upwards. I suppose I can have a quick look at it. What are we on there then in power wise? 19.08 special. That's 10 watts. If I crank it up a bit to, let's run it at about 30 watts so it's not too overdriven. And set back to AC level and ratio and log. So that's at the reference of 1 kilohertz. Let's go down to 30 hertz. So it's minus 2.5 at 30 hertz. Okay, let's go right up to 100. Plus 3 dB. Okay. 200, 3, 4, 5, 6, 7, 8, 9, 1K, 2, 3, oh, it's going down now. But this is the base input, so I don't know, and as I said, I don't know where the tone controls should be. I mean, if I turn up the treble, that of course gets better now. So it's a bit of a meaningless test really, so I won't do any more, because really you're just going to stick some music into it, aren't you, and see if it sounds, and adjust the tone to what sounds good. So that's about it, I think. Turn off the generator, so I finished testing, and there it is, the hideous thing. Now I'm going to stick it back in its case and get rid of the bloody thing. I never want to see it again in my life. I'm not a fan of valve stuff at all. I may, for an experiment, upload this in 720p, because the last video I did took nearly 12 hours to upload it to 1080, and while I'm uploading I can't download, so you've got all that time without access to the broadband, which is really annoying. But as I can't afford fibre, I'm stuck with a slow upload. Anyway, I hope you enjoyed that. My first foray for many years into valve equipment. So give me a thumbs up, whatever. Bye for now.